Hello, welcome to today's lesson on section 13.4. 13.4 is about evaluating inverse trig functions. Now, I didn't create a worksheet, but you might want to take notes, probably on a separate sheet of paper or a notebook. There are three inverse trig functions we're going to look at. There's sine -1, cosine -1, and tangent -1. These three right here are called inverse trig functions. And they're really not too bad. Say, for example, sine theta equals 1/2. To isolate theta, you must use sine -1. And by the way, sine -1 is not 1/sine. Instead, what you would say is you would say theta equals inverse sine of 1/2. So basically, inverse sine will undo sine. Just like how logs undo exponents, or plus undoes minus signs, or multiplication undoes division, or how square root undoes something squared. So that's all inverse sine really is. It's a way to isolate the angle that you're taking the sine of. So it isolates theta. Likewise for inverse cosine and inverse tan. So say, for example, asks you to find the inverse sine of root 3/2. So whatever you put inside here will always be a ratio of two sides of a triangle. And the result will always be an angle. So you look at the unit circle, where do you see root 3/2 for sine? If you think about it, remember sine theta is like y. Oh, what do you know? I see it right here, and I also see it right here. So what this means is that inverse sine of root 3/2 will equal 60 degrees, or 120 degrees. That's because the sine of 60 degrees equals root 3/2, and the sine of 120 degrees also equals root 3/2. Are there more values that inverse sine of root 3/2 can equal. Think about it. Are there more values? The answer is yes. For example, inverse sine root 3 over 2 can also equal 420 degrees or 480 degrees. Because if you go around once, that's 360, and go around 60 more degrees, you get back to the same place at 60 degrees. Or you do that and get the same thing. So there actually are infinite values. There are infinite possibilities. So here's a question. What answer should I give? Usually what you should do is the default. The default answer for inverse sine will always be this. Or in radians will be this. So let's try another example. Let's find the inverse sine of negative 1/2. So if you think about it, going back up to the unit circle, we want to see where y is negative 1/2. Oh, we know it's right here. It's also right here, but the default is from negative 90 to 90. Remember, that's negative 90 degrees, and that's 90 degrees. And this will cover all possible inverse sine values. Because if you think about it, right now sine is negative 1 at negative 90 degrees, as you see over here. And then it starts increasing from negative root 3 over 2, negative root 2 over 2, negative half, then it gets to 0, then it gets 1/2, root 2 over 2, root 3 over 2, and then 1. So in this case, we're going to go with negative 30 degrees as our answer. Because you got to travel negative 30 degrees for sine to be negative 1/2. So it's negative 30 degrees because the sine of negative 30 degrees will equal negative 1/2. What it also means is that the domain for inverse sine will be the following. Or actually, we should probably use an x. The domain will always be between negative 1 and 1 for inverse sine. Simply because the sine of an angle can never be larger than 1 or smaller than negative 1. We'll take some time to think about, talk about this on Friday. But sine theta can never be larger than 1 or smaller than negative 1. So let's kind of recap everything I've discussed so far in this video. We talked about the inverse trig functions. There's sine negative 1, cosine negative 1, tan negative 1. Inverse sine is not 1 over sine. Don't confuse those two. Remember, 1 over sine is cosecant. So sine negative 1 is not 1 over sine. Say, for example, you need a sine of some angle equal to some value, like 1/2. To isolate theta, you must use an inverse sine function. It allows you to isolate the angle that you're taking the sine of. So just like how logs undo exponents, addition undoes subtraction, multiplication undoes division, square roots undo squares, inverse sine will undo a sine. And so we took the inverse sine root 3 root 2, looked at the unit circle, we saw that sine of 60 degrees gets me root 3 root 2, sine of 120 degrees also gets me root 3 root 2, and there's more values at work, but we tend to stick with anything between negative 90 to 90. That's the default for inverse sine. Or in radians, negative pi over 2 to pi over 2. We did one more, and we also saw that the domain for inverse sine has between negative 1 and 1, and we'll discuss this when we see each other again on Friday. We'll talk about inverse cosine and inverse tan on Friday, just so you see how that works, but it works the same way. But at least I kind of got you guys thinking about it, and we'll do more of this on Friday as well as on Monday next week. Okay, I'll see you later.